Your attention is drawn to the presentation of the work on the development of technology for the phosphorization of iron ores with a high phosphorus content. The problem of developing an effective technology for the phosphorization of various iron-containing concentrates which reduce their phosphorus content is of great particular interest to many countries around the world. This is because the presence of phosphorus negatively affects the process of steel smelting. It complicates the process and increases the cost of smelting, leading to cold breaking brittle steel. The purpose of the work: development of an effective technology for the phosphorization of various iron-containing concentrates, magnetite, hematite, hydroxide. In order to achieve this goal, the following tasks were set and solved. Perform an analysis of research and publication of the world's modern methods of the phosphorization of iron-containing concentrates. Examine the features of the mineralogical and chemical composition of magnetite hematite ore with a mass fraction of iron of 53.8%. Determine the feasibility of the contamination of magnetite concentrates and direct flotation of apatite from hematite concentrates. Investigate the leaching conditions of poor hydratite concentrates with high phosphorus content at high and low temperatures. Analyze the result and provide recommendation for reducing the mass fraction of phosphorus in magnetite and hematite concentrates. As a result of mineralogical examination of magnetite and hematite concentrate, it was determined that the main carrier of phosphorus in concentrate is apatite. The grain size of apatite varies widely from units of micrometers to tenths of a millimeter. Apatite is concentrate in a fine fraction of less than 20 microns. Based on the analysis of the results of examining the material composition, chemical and mineralogical properties of magnetite and hematite concentrates and the properties of apatite, it was concluded that it is advisable to conduct desalination of magnetite concentrates and flotation of apatite. The contamination operation magnetite to reduce the mass fraction of phosphorus from 0.071% to 0.03%. During the second stage of research, direct anionic flotation of apatite was performed on the hematite concentrate sample. The best indicators for the phosphorization were obtained at the consumption of reagents, MDTM 500 gram per ton, starch 2500 gram per ton, soda 1000 gram per ton. During direct anionic flotation, most of the hematite aggregates pass into the foam products, which leads to large losses of hematite with a foam product of 75 to 85%. So further studies were conducted on the direct cationic flotation of apatite. The Lilaflot reagent was used for direct cationic flotation of apatite. Lilaflot reagent is a mixture consisting of 60 to 80% alkoxypropylamine and 20 for 40% alkoxypropylamine acetate. According to its high toxicity parameters, the product can be classified as a moderately dangerous substance of hazard class 3. Feasibility of using reverse cationic flotation. Low consumption of cationic collectors, slightly more than 0.1 to 0.15 kg per ton. Possibility of flotation in water with high rigidity with high efficiency of the process, small output of foam product, high environmental safety of the technology due to the almost complete adsorption of amines, cationic collectors, on the surface of the solid phase of the flotation pulp, and then on the surface of the particles then make up the magnetic enrichment tails when mixed their products in the tail trays. As a result of a series of tests in hematite concentrate, it was possible to reduce the mass fraction of phosphorus from 0.343 to 0.20%. The mass fraction of total iron in hematite concentrate increased by 2.4% to 64.88%. In the third stage, the conditions for leading poor hydroxide concentrates with high phosphorus content at high and low temperatures were analyzed. Firing was conducted at a temperature at 900 degrees Celsius for 1 hour. Leaching was performed with sulfate acid at a concentration of 49% for 1 hour. As a result, a concentrate with a mass fraction of phosphorus of 0.15% was obtained from a concentrate with a mass fraction of phosphorus of 1.2%. Based on the result of the work, the following recommendations were developed. First, it is sufficient to use the contamination operation in the enrichment technology of rich magnetite hematite ores to extract phosphorus from magnetite concentrates, which can remove up to 61% of phosphorus. Second, for effective dephosphorization of hematite concentrates, direct cationic flotation and apatite is necessary. This process removes more than 74% of phosphorus from the concentrate. Third, the proposed technology for leaching samples for poor hydroxide high phosphorus concentrates at high and low temperatures suggests that the firing process parameters allow the recrystallization of iron and therefore contribute the access of mineral acid at particles containing phosphorus. Thank you for your attention.